Okay, we're not going to do the 16th question because it is the dito as the 17th question. 15th question has already been done. So we are on to the 14th question. Uh, it says the length x of the leaves of a particular species of trees are normally distributed with mean, mu, and variance sigma square. So like we given that x is normally distributed with this mean and this is the variance over here. Achha, it says find the probability that x is between this and this. This is this actually means that x is within one standard deviation from mean. Okay, and if you go through the key features of a normal distribution, people enter and all this is messed up. Okay, so if you go back to the the properties of a normal curve, so you see nearly two-thirds of the data lies within one standard deviation from the mean. So this is the area over here. This has to be two-thirds. So this should be two-thirds, but if you look at the answer here, that is rather than this is the 14. This is point. This is the answer here. Let me highlight this. This is the answer. This is approximately two-thirds because 2/3 is 0.67. Okay, 6.67. So this is 0.683. So that means we'll have to calculate this. Okay, so let's go back to the book then and let's calculate it. Okay, um, so it is here. Okay, so yeah, it says this is okay. So we have to find this probability. So we have to find this probability that x is between mu minus sigma, mu plus sigma. This is within one standard deviation from this mean. So we have to, when you standardize this, all of this would become, so the formula that I'll be using, that is z is, this z is x minus mu over the standard deviation. Okay, so this is my x right now is here. This is mu minus sigma minus mu over the sigma. So using this formula right here. Okay, and then this one is mu plus sigma minus mu over this mu. And when you simplify this, this is the probability z is between, you see this is cancelled with this is cancelled with this, minus sigma over minus sigma is -1, and this is going to be 1 here. So that is phi of 1 minus phi of -1. So this is phi of 1 and minus into 1 minus phi of 1. This gives us 2 phi of 1 minus 1. So let's see what is phi of 1 here in the table. Phi of 1 is going to be 1.00. This is 1.0.8413. This is 0.8413. Twice into 0.8413. 0.8413 minus 1, and let me use a calculator. This is 2 into 0.8413 minus 1. This is 0.683. 0.683. That is our answer to this question. Okay. And then we go back to the question. It says, find the probability that a randomly selected leaf from this species has a length that is more than 2 standard deviations from the mean. Oh, it is more than, it doesn't say between the 2 standard deviations. Okay, so guys, be very careful with the statement here. So he's actually asking you, let me show you this to the diagram here, this B part. Okay, if this is the mean here, this is the first standard deviation here, and here are the two standard deviations, and then here is the third standard deviation here. It says more than two, so it is either this or it is, he's asking for this area. So he's asking to find the probability z is greater than mu plus two standard deviations, or probability z is less than this is mu minus two standard deviations. Okay,
लेकिन
so
सर फिर इन दोनों की तो प्रोबेबिलिटीज इक्वली होंगी ना, तो हम एक का ढूंढ के डबल
बिल्कुल,
ना कर दें फिर?
exactly you can do that. Let me just make a correction here. It shouldn't be z here, it is basically x here. Okay, so this is x, this is x. Okay, so yeah, you're absolutely right, they're both the same. So I'll just be finding one and then I'll be doubling that. Okay, so let's just find this one, because this is obviously a symmetrical curve. So let's just do the working over here. So this is going to be probability that z is greater than this mu plus 2 sigma minus mu over this sigma. Okay, again using this formula. So this is cancelled by this. This is going to be probability z is greater than 2. So this is 1 minus phi of 2. So let's see what is phi of 2 here. Phi of 2 is 0.9772. 0.9772. 1 minus 0.9772. So 1 minus 772. So this is 0.0228. And your answer, final answer, is going to be twice this, because there's an addition between them. So this is going to be 2 into 0.0228 times 2. This 0.0456. That should be the answer here. So here is the answer to this question. So this is like, the answer to this B part here. Okay, guys. So that was the, I think, the second part. And then it says, find the value of mu and of sigma for this and this. Now this is, if you just go through this question carefully, guys, this is again going to be a situation where you will have two simultaneous equations for the C part, and then you will be solving them. Okay, let me finish off this solution here. So it says probability x is less than 7.5. Probability x is less than 7.5 is 0.75, and the probability x is less than 8.5 is 0.90. So you standardize this, you get probability z is less than 7.5 minus mu over the sigma, that is 0.75. Okay, so this is phi of 7.5 minus mu over sigma, that is equal to 0.75. And this 7.5 minus mu over sigma is going to be phi inverse of 0.75. Let's see what is phi inverse of 0.75. So where is 0.75? It is here, 0.75. Yes. So this is 0.7486. And we add this 13 into it. This is nearly 0.75. This is 0.6378, 0.684, 0.684. This is 0.684. So we have an equation here. Let me write this in a different color. That 7.5 minus mu, that is 0.684 sigma, that is equation number 1. Okay, and from this second information we have here, this is going to be uh, probability, we standardize this, less than 8.5 minus mu over this sigma, that is equal to 0.9. Okay, so this phi of 8.5 minus mu over sigma is going to be 0.9. This 8.5 minus mu over sigma, that is going to be phi inverse of 0.9. Let's go to the table, and oh yeah, the table is right here, 0.9. Where is 0.9 over here? 0.9. Yeah, this is 0.8997. I can add this 2 into it. So this is 1.281. 1.281. So my second equation over here is going to be 8.5 minus mu, that is 1.281 sigma. That is the second equation. Guys, you can solve these two equations simultaneously to get to the value of mu and sigma. So I keep it up to here. Let me just give you the solution. You can see the answers should be here. It is, yeah, you must get, after you have solved them simultaneously, your sigma should be 1.64 and your mu should be 6.39. So these are the answers that you will be most probably getting if there is no silly mistake made here. Okay, that is it from this session.